What we call a differential equation is an equation which contains differential coefficients. So what we have here is a differential equation because it contains dy dx, which is a differential coefficient. It is first order because dy dx is a first derivative. If it contained a second derivative, it would be called a second order differential equations. What I'm going to explain in this video is the method that you can use to solve a differential equation of the form dy dx plus py is equals to q, where the p and the q are functions of x. So p is actually a function of x and q is also a function of x. If we have a first order differential equation in this format, then the solution to that differential equation is this: y multiplied by e to the power integral of p dx equals to the integration of q times e to the power integral of p dx. All you're doing here is identifying your p and your q. Then you find this integral here, integral of p dx, and you substitute that into this formula. You are usually given this formula. So all you have to do is finding your p and your q, then evaluating the integral of p dx, then you substitute into the formula. That's what we're going to do. So I'm going to explain this using an example. So let's write down the example, the question that I have here, the question that I'm going to use. We are required to solve this equation. It is a differential equation, 1 over x dy dx minus 1 over x squared y, which is equals to 3x minus sine x plus cos x. I cannot identify my p and my q until this whole equation is written in standard form. We are also given some values of x and y. They said when x is equals to 1, y is equals to 1. There is a reason they gave us these values, because they want us to find what we call a particular solution. So the solution that we're looking for here is called a particular solution. There are times that we are required to find what we call a general solution. In fact, before you find your particular solution, you should find your general solution. A general solution contains the general constant called c, whereas in the particular solution, we actually have a value of this c. If we have the value of c, we have a particular solution. If we don't have the value of c, we have a general solution. We are given x and y so that we can evaluate our c. Very, very important for you to note that. Now, I want to do the first step, which is to write my equation in standard form. If this equation is in standard form, I should just have dy dx here. So I have to remove the 1 over x. I have to remove this 1 over x. How do I do that? I multiply throughout each term by x. If I multiply by x throughout, I will be left with, I'm going to write this in green. If I multiply by x here, I get dy dx. I multiply by x here, I have minus 1 over x y equals to 3x squared minus x sine x plus x cos x. Now I have my equation in standard form, I can identify my P and my Q. From here, it's quite clear that P is minus 1 over X. This is my P, and Q, all this is Q. So Q is equals to 3x squared minus x sine x plus x cos x. Very important that you identify your P and your Q accurately and clearly. So now I have my P, I also have my Q. I can now move to the next stage, which is getting all these integrals of P dx that I can now substitute into my solution formula. We already have the solution formula. All we need to do is to get all the elements that are in the formula. Then we substitute them there, and then we do the integration. I'm going now to clear the board and then write this clearly. I have P equals to minus 1 over X. But if we look at our solution formula, we have this term written as e to the power, the integration of P dx. Let me find this first, integration of P dx. So if I integrate P dx, it means I'm integrating minus 1 over x dx. And if we integrate minus 1 over x dx, the answer is minus ln of x. But from your knowledge of logarithms, if you know the laws of logarithms, you can write this as ln x to the power minus 1, which is essentially ln 1 over x. So the integral of P dx is actually ln 1 over x. This is a very important step. So find this aside before you substitute into your formula. Look for all these parts of the formula before you write the formula and substitute. So I now have my integral of P dx. I want to put it back here and simplify. Usually when you do that, you're going to be left with something that is quite easy to work with. Let's do so. I'm going to write it here. If I say e to the power of the integral of P dx, I'm actually saying e to the power of ln 1 over x. If you know your laws of exponents, you will know that if I say e to the power ln a, my answer is a. This is a fact. It means from what I have here, e to the power ln of 1 over x is actually 1 over x. This is 1 over x. So I now have e to the power integration of P dx. I now have that part. I can now write my formula and substitute and do the integration all at once. So let us move on. We have y e to the power of integration of P dx being equals to the integration of q e to the power of integration of P dx. This is our solution. I will call this the solution formula. So I have here my solution formula. It is given in the formula sheet. On the formula sheet, you have this, the solution formula for a first order differential equation of the form dy dx plus py equals to q, where p and q are functions of x. This is the solution formula. All right, Now, once I have my formula, I'm simply going to substitute all these elements that I found. I'm just putting them into the formula and doing the integration, or if I have to just do some simplification, I'm just doing that. That is the next step. So y is y. Let me write this as y. Okay. E to the power integral of p dx. I said that is 1 over x. I found it as 1 over x, so I'm just putting it here. Equals to the integration of, I know my q, and I know my e. So this part here is 1 over x. I'm multiplying it by q. I just wrote this first. You're allowed to do that. My q is 3x squared minus x times sine x plus cos x. Not cos x, x cos x. Dx. I want to highlight that this is my q, and this part here is e to the power of integral of p dx. You find these elements, and then now you're just putting them into the formula, and then you do your integration. I want you to see something here. If you look at this term and this other term, you cannot integrate them unless you use integration by parts, which makes the question very difficult. However, because you are multiplying everything in the brackets by 1 over x, it is going to simplify all these terms there in the brackets. They become easy to integrate. Okay, so to the left-hand side, we now have y over x. To the right-hand side, we have the integration of, if we multiply 1 over x, multiply 3x squared, we get 3x. And this term here becomes just sine x and plus cos x dx. Now everything that is in the that we have to integrate is quite straightforward, and we can do that. So this is now y over x. If we integrate 3x, we get 3x squared over 2. If we integrate minus sine x, we get plus cos x. And if we integrate cos x, we get plus sine x plus c. I want to say what we have now is a general solution. If the question was asking about the general solution, we have it now. However, because we're given the values of x and y, it means we are required to find the value of c. And if you have the value of c, you have what we call a particular solution. That's it. But if it was just about finding the general solution, we have it now. Okay. So now I'm going to rewrite this and solve for c. If I'm looking for c, I just transpose all of these to the right hand side. So let me rewrite the solution and find our c. So we have y over x equals to 3 over 2 x squared plus cos x plus sine x plus c. I'll just move all these to the right, to the left, and I get my c. It means c is equals to y over x minus 3 over 2 x squared minus cos x minus sine x. We were told that x is equals to 1 when y is equals to 1. Now I'm just going to substitute into this equation here. So we have 1 over 1 minus 3 over 2, 1 squared minus cos 1 minus the sine of 1. Okay, this one is a 1. You punch in your calculator, you get the value of C. If you punch in your calculator, your C to 3 decimal places is minus 1.882. Minus 1.882. That one is your value of C. It means now I can write my final answer. Okay, let me remove this. Okay. Okay, from my general solution, this is my general solution. I can rewrite it as y equals, I'm multiplying by x throughout. Every time I'm multiplying by x, this will give me 3 over 2 x cubed plus x cos x plus x sine x plus cx. I call this the general solution. This is our general solution. The particular solution which they said we should find is simply y equals to 3 over 2 x cubed plus x cos x plus x sine x plus cx, which is minus 1.882x. What I have here is the particular solution. We call this the particular solution. Now I have solved the differential equation. And as I said before, when you're solving a differential equation, you are removing or you are getting rid of differential coefficients. It is called a differential equation because it has differential coefficients. If you have solved it, you have removed or you get rid of differential coefficients. That's what we have. It is called a general solution if it is containing the general constant called C. But it is called a particular solution if we now have the value of C. Okay, thank you for watching the video. If you have any questions, just write in the comment section below. I will respond. Otherwise, thank you for watching.